We ready?
Yes.
Have we started already?
Yes.
Okay. Let's start talking about chemical kinetics. This means that when we have a set of atoms, a set of composites, or a set of another kind of matter that is going to change over time into something else, another set of atoms, matter, or anything else, is what we are going to call as chemical kinetics. Do you remember why there is physical change and chemical change? No?
No.
Okay. Remember, when we have something that happens outside of the internal arrange of matter, we are having a physical change. When change happens inside the structure of matter, we have change. Now, is change instantaneous? El cambio ocurre a través del tiempo o inmediato. Does change happen instantaneously or over time? Over time. Excellent. So, if it happens over time, there is something I want you to learn anyway. Okay? I want you to learn that time is on our side because changes are going to happen over time. They are not instantaneous. Usually, when we study chemistry, they tend to happen instantaneously or we forget about time. We only put some kind of chemical reaction, as you studied previously, and turn it over into another thing. Now, this can also happen with nuclear reactions. This is not really important for you, but do you remember another kind of chemical reaction? Remember, I need you to participate. Please.
Okay.
Come on, write me down another reaction that you can kind of remember. You don't? Come on. Okay. Yes, help me out. Please help me out. They need to see that you are taking part of the class. Please help me. Okay. The most important one for you, because you're studying biotechnology, is this one. Oh! You must remember one. Yeah. No? Okay. Glucose transformed into CO2 plus water. Which kind of reaction is this one?
Chemical.
Yes, but being a chemical reaction, it has a very specific name, especially because it requires heat.
Exothermic.
Almost everything is exotropic.
Exotropic.
Why? Because the amount of energy that you require to do anything gets higher. So it's exotropic. But you are thinking about exothermic. We'll talk about that later. It is called combustion. Do you remember?
Yes.
The transformation that it happens is that long carbon chains are transformed into inorganic compounds. So, at the beginning, this was if these are inorganics, what kind of... Thank you very much. So, which kind of chemistry are we going to use if we have inorganics and organics? Do you remember? We have two kinds of chemistry, the inorganic chemistry and the organic chemistry. So, which one are we going to use?
Organic? Organic.
No, we're going to use both. Remember. And also, there is a very interesting step that we have something organic that becomes inorganic. And when we had the urea transformation, I mean, starting from something inorganic to something organic, producing urea, then we had something that went from this side to
This side.
okay. I said that we don't really care much about this process as it is drawn. We care about time. There is another phrase that we need for this class, which is equivalent exchange. I shouldn't be saying this, but toca coca. You cannot earn something if you don't give anything in return. So we give something and we end up with something different. Okay? Remember, mass should be conserved. Does anyone remember how to write that in a mathematical language?
The continuity
Equation. Excellent. So it was written as
E equal
the
S.
change of mass over volume in time adding the behavior throughout each movement must be equal to zero. Here is where the interesting part starts. If we have this one and this one, those are components of chemical species. So we have two components that must disappear in order to become something else. How many equations do we require if we have three components?
Three.
So sodium,
One for the
sodium,
hydrogen, another for the iodium, and one for the compound.
yeah.
Okay?
Sodium plus chloro. I don't know.
This is not chloride.
Uh-uh.
No, it's
it-
iodine.
It's a
Remember,
base.
chloride.
Yeah. Okay.
Remember, we are trying to show our best. Help me out a little. Now, it is easy to see that we need to add components. And of course, this expression can be better understood if we write down its whole derivative. Remember, at least to me, index fingers are better to remember which one is an inner product, over the equation that must not be held into itself. If we have three components, then we can write that the mass of hydrogen, the mass of yodium, and the mass of the anhydride, yodium anhydride, I hope it's the name, still it's the compound as you say, had to be added in order to recover the initial equation. So, in another terms, the accumulation must equal the inlet subtracting the outlet, oh sorry, plus what? What am I missing here? Come on, say it out loud. Production or product minus the reaction, not the rate, the reaction. Here comes a very interesting set. If we are choosing to say that this change has to be this letter, then we can understand rate. Usually in Spanish books, this is translated as just this word. Don't say it, just remember it. Is it a velocity? No. Why? Because it doesn't even have the same measurement. It doesn't really have length over time. Because it doesn't have this, it is the whole world. The whole world. Rate represents all this idea. The word we do have to change this, it's with S. Remember, with C, it says another thing. We have this word. Why am I telling you this? Because usually when you go and read, you're going to find this. And usually, even I commit a mistake. It is very easy to say, instead of rate, in Spanish, velocidad de reacción, the rate of reaction. In English, it's very well defined, but here in Spanish, we have to use this word. Okay?
Yes.
Thank you. If we have a rate, then we have a derivative at least over time. If we have something over time, before that, can somebody help me to change the density for something else?
For the concentration?
Yes! Can you help me?
Not, not very well.
Come on, come on. Let's look at this.
Yes.
If we have density, we must have mass over volume. If we have concentration,
Moles number.
moles,
Over volume.
volume. It is easy to see that if we have something one side, we can change the other. But there's also another way to come out with the moles and the concentration. Do you remember the volume? It's harder to identify that V from this V. PV equals
R and T.
And T.
R T. So we put this volume under the nRT part. Which part is which? This part is
Energy.
excellent. It's the energy related to the system. As its pressure and volume. And this part is
Mass.
not really. No. Concentration is going to be as soon as we divide this.
Pressure.
Come on.
Area.
This is allegedly the activity a system can uphold, or at least a system can have. Why? Because it's related to its internal energy, a constant that you must remember. It's calculated as this one. I will forget always, and I don't care. What's this? Heat capacity at constant pressure and heat capacity at constant volume. I can be mistaken. Please check this equation as soon as you are able to. Please. But still, it's something like that. But still, remember, in so many units, this can change its value. But still, one very common for us is 0.802. 0.82, yeah, liter atmosphere over mole Kelvin. Why is it important? Because it's a subtraction. Still, that's why it is the activity the system can uphold. So the amount of energy that we have to do some kind of change relates to the amount of moles according to its pressure. If we remember that moles over volume turns out as this expression. We can also turn down this part, put it in here, and keep the concentration as a measurement of pressure, but it will be the partial pressure.
9:30 o'clock.
We still have time. So, we've been using time to introduce that. I've been looking at you, and I think we still have something to work with this. And let's start to say how we are going to measure the change of concentration to measure the change of matter. So the transformation that takes place, can I erase?
Yes.
Yes.
Thank you. This one I'm going to use it. Unfortunately, I did not teach you mass transfer. If I had, then I will be just writing this. The change of any concentration over time must equal the speed at which it's translating, the amount of the angle, and of course the direction. So this is a vector. Remember, for what was used this expression when it was multiplied by matrices? Yes, the dot. It was the inner product. But I told you, when we have nabla, that operator, or the derivatives over position, and any property, let's say the concentration, what is it telling to me? Make an effort. Remember, yes, divergence, gradient,
And rotational.
Okay. Rotational doesn't really hold. For us, in English, this has to be a curve. Why? Because the rotation is what the earth does in English. In Spanish, we do have that word. In English, it is the curl. Why? Remember, it's related to the other direction in which the flow it's not really applied. That's why it changes its name. Let us think, for easiness, and let me write down the R, because these two are disappearing. Okay? Remember what was written in the blackboard? Whiteboard? Whatever. We have what is coming in and out. If we think on the system you've been using half of your life, a glass and fluid substances that change color or release heat or whatever, then we don't really have much to interchange between inlets and outlets, do we? Usually, when you work with a tank, something comes in and something goes out. But when you work in the lab, usually you have a very small vessel we call, how do we call this in the lab? Did you forget?
Could you repeat the question, please?
Yes, what's the name of the glass that you use?
Precipitate glass.
Kinda.
Baker.
Let's take everything you have to say, and actually those are correct answers because that's what you've been using. Still, it is
Not really a tank.
it is a vessel, and does it have inlets and outlets, or you leave it closed or even open, but not really pouring anymore or subtracting any more material? You just leave it there, right? So, for starters, because you start with that, we can pull this out. No speed means no inlets, no outlets. So, all the change is going to be related to the transformation of the reactives into products. A ver, cuando no tenemos entradas y salidas, tenemos un sistema cerrado. Como no tiene entradas y salidas, quitamos esto. We take this out. And we only have, solo tenemos el cambio en el tiempo y la relación con la que se transforma. We only have the change in time and the relationship or the rate at which it's transformed. What? Either this one or this one or this one. Here comes the interesting part. We have to define this. And we have said that the amount of, let me change a little bit the notation again. This time for our convenience, we'll write down H2 between this kind of brackets. Why? Because like this I can remember its concentration. Okay? This means equal.
Aproximadely.
No.
Inversamente proporcional.
The second part was okay. The first one not.
Inversamente proporcional.
No. The first one inversamente no.
Proporcionalidad.
So this is proportional to the amount of concentration that we have. And now, in order to transform the proportionality into equality, what do we need? Try to remember force equals mass and acceleration. The force is proportional to the acceleration. And it turns out this is, what is this?
The mass of
The constant that makes the proportionality equal. So we need something to make the proportionality the equality.
the reaction velocity.
Not really the reaction velocity. That is what we are measuring. What we need is the constant that relates the rate of reaction. So
K. Bueno, K.
K, it's going to be our constant.
Yeah.
And this constant, it's not really that constant.
Not because
It changes all the time.
Yeah.
It changes because of its temperature, its pressure, even when it's not really related to the concentration that we care, still it can change the rate of reaction. We'll talk later on this, especially when we have moving fluids it behaves so badly. It makes changes over the density and other related stuff, so it's very important. Pressure, concentration. Do you remember this? What's this?
Viscosity.
No. All together.
Inside.
Can somebody tell me why do we expose bacteria to ultraviolet light? ¿Por qué exponemos a los bichitos a luz ultravioleta?
Para esterilizarlos, para matarlos.
To kill them, right?
Yeah.
So, if we have a photoreactor, we can have this. This is luminic energy. Unfortunately, this is the same as viscosity, which is also important for the rate of reaction. And of course, it's constant. And we have so many things here that I wouldn't finish to enumerate everything. The amount of sun, the amount of humidity, everything carries. But there is something that I am leaving out, which is, what was this? Did you forget already? What was this? This is a concentration that is being transformed. So we put everything that is not concentration under the constant. And then we pressure the concentration as another term. And we have an equality. And since allegedly none of this will change over time, we can turn this kind of derivative into the other one that you're more familiar with. I hope. And what's this? Come on, I know you can remember. What's this? From the mathematical point of view. It's an ODE. And ordinary differential equation, which can be solved, right? Let me put this away. And let's take everything else out. Just remember for the concentration is going to, oh, remember, if it is a reactive, the sign is negative. If it is a product, the sign is excellent. So we are going to leave the sign as we need it. But we need to solve this out. I need two volunteers. One that solves this one. Just 2 steps. Come on. I know you can solve. And the other one that is not that hard, which is this one. Please, step up. You don't even have to talk. Please, just step up. So, the one you like the best. And I'm sorry. I know you can solve the other one. Yes, integrate. Actually, it's more like solve the ODE, but yes, if you put this one under and this one happens to be here, it will be an integration. One side and another side. Please, do your best. So, you liking the class? Yeah. Okay. So. I'm doing the rest.
Teacher, in what situations is an integration?
So, how's everyone doing? Can somebody else help, please? Me. You're missing the consent. And still, we need to do some evaluation, but we need that result also. Please, someone else help me. Yeah.
It's like
It's just starting to see that you are in 7th term and you still don't manage these ones. But you have to study, okay? How much hydrogen can I have at the beginning? How much should I have at the start of the reaction? As much as possible. How much is it? I don't know. But still, it has to disappear over time. And when it finishes, we are done. So, we have two expressions in order to tell that tale. If this is constant, when we have 0 equals C, then we have the value of the initial amount we have of either this one or this one. Why? Because of the initial value. Remember, this is a variable separation procedure which also must be held into an initial value. This comes from your differential analysis. Remember, I am not going to waste much time here, but you have to keep in mind that this is something you already know. So we change the value, and now we have the initial amount. So it is easy to see that if we have a product, then we put a plus and more amount. It's created over time. But as I was telling you, if we have a reactive minus sign, then we start with something and it gets destroyed over time, or not really destroyed, it gets transformed over time, and we end up having some amount of concentration which is minor than C0. This equation also has another problem. If I keep going forever, I can end up having negative concentrations. Is that okay? To have negative concentrations?
No.
No. So there is a point to stop when we have this equation. We have to be careful that when it reaches 0, then we have to stop. Okay? Now, that it's not fully solved again, and we have to use the anti-logarithm function. Do you remember which one is it? Remember the E number, the Euler number. We have that the concentration equals the exponential, the transcendental exponential function of plus minus k t. Since there is a plus and I am putting the exponential function, we are adding the exponential of the constant. What happens again when we have t equals 0? Then we have only the exponential of the constant. Why? Because this one becomes unity. We write down this expression. I change this for a C0 because this way I can compare it to this. Now we have plus minus kt, and those two are my expression, which I am going to draw now. I need some help again. No. I'm not gonna write you. Come help me, please. You can work this out in your notebooks way better than I am doing. But still, let's say that at the beginning we are measuring some reactive. So we have it here at the beginning. What form does this have? Do you remember y equals mx plus b? What's that? See the curve, a line, What is it? Excellent, it is a line. Yes. So, let's say that we have at the beginning all these units. Then, advancing, we have a dot here. Or at least what it looks like. Then, when we advance, it has to decrease a little bit more. So we have another dot. Then we have another dot. And finally we reach 0. So with this information, since K was the slope of the line, we can measure it up. And we have a full expression for a 0 order change of reaction. Can you put the straight line? Thank you. It's a straight line. Thanks a lot. Yes. Now we are going to draw the second expression. We start in the same position. Let's put it in blue. Right here. And now we have that at every time we have half of what we used to have. So put half in the first step. Now put half of it at the second step. Okay, just leave it like that. Now half. Half. Now put half. You can still go on. Half. Now, draw the line. As you can see, thank you very much, you're most kind. We have straight line for the and a curve, a very specific curve for the first order. I think we are running out of time. So we got some useful expressions, and I want to do some final remarks about what is happening. We are measuring a set of how things disappear. As I told you in this class before, if something is disappearing, then something must come out of it. That is what we are going to check next class, okay? Okay. And also, another important thing that we have to mention is that these two are not the only expressions that we can have. As you may remember, sometimes things can be a little bit more difficult, and also reactions may turn into the other direction. And now the product is the reactive, but here we have one constant expressing that direction. We need a new constant to express territory. And when we put them together, we can have equilibrium, which is another idea we are going to try to deal with next class. Thank you very much.